Hello, welcome back. Today I'm going to be doing some continuity and intervals of continuity problems. So, our first problem for practice is the following. So we want to find the value of c such that f of x is continuous for all real numbers. So let's think, what value of c would make this true? Now, instead of just staring at the problem and hoping that the solution will come to us, let's actually start taking things into our own hands. First, let's figure out if if it could possibly be continuous for values less than 2. So in this case, we're going to take the limit of f of x as x approaches x naught. Always the thing you have to write when doing continuity. Um, Limit is equal to the function's value, and in this case, it is. And for the second one, from 2 to infinity, we have that. And notice here's where we have the c part. We're still going to get c of x naught plus 6, which is f of x naught. So we're not getting any limits to what c could be. C could still be any real number. Here's where things get tricky. At x equals 2, we want the limit of the function at 2 to be the function evaluated at 2, which is also equal to 2c plus 6, meaning we want the side limits, which in this case on the left, we just get 7, and on the right, we get 2c plus 6 to be equal to each other. So in that case, we have this whole thing, but we'll just look at the c part, and we'll get c has to be 1/2. So if c is 1/2, f is continuous over the real numbers. Now for a second problem, it's a bit long, but we're gonna focus in, and I'm gonna give some hints before I start in case you get stuck anywhere. So determine the values of b and c so that's continuous on the entire real line. Okay, so just like the last problem. Now, like the last problem, we probably want to do something, similar, but it's a bit harder this time. So our first hint is to express the absolute value of x minus 2 greater than or equal to 1 as an interval because I hate to say it, but that's kind of confusing. I don't even know what that's supposed to mean. So let's, do something with it and express it in an interval. So in this case, actually, both of them would just be this. By our disjunctive inequality, we're going to get, of course, just this and the or this, which is this or this, which is in an interval notation, the union of those two. Recalling that union is when you have or, a disjunct. Now, if for the second one, what is our second hint? We want to determine continuity in the interior. Okay. Our third hint is to determine continuity at the bounds, so 1 and 3. And our final hint is to combine any equations we have into a system of equations. So we haven't gotten there yet, but let's start off with the second one. So we're gonna consider this interior. Now you can consider -1 to 1 and 3 to positive infinity separate, but I'm just gonna consider the union of them because either way it doesn't make a difference as long as we let x not be in any of those two intervals. We get the following f of x naught. Again, no limits so far. B and C can be any real numbers. Here we have between 1 and 3, and in this case, it's going to agree with the first piece, which is still f of x naught. So no limits. Now, step number 3 is to determine at the bounds 1 and 3. So at x equals 1, the limit of f of x as x approaches 1, we consider first the side limit, and that agrees with the second piece, which is b plus c plus 1. And the other limit is just agreeing with the first piece, which is just 2. Okay, so we have b plus c plus 1, we have 2. What can we do here? Remember, the side limits, in order for it to be continuous, the side limits have to match, right? Otherwise, the limit does not exist, which means it's not continuous. So the side limits have to match. Remember, if they don't match, that's a type of discontinuity, meaning b plus c plus 1 equals 2 or b plus c equals 1. So now we do have a restriction on b and c. Their sum has to be 1. And moving on to the next one, we have at x equals 3, the limit as x approaches 3 of f of x is just, well, okay, first we'll consider one side, and in this case, we're going to have 4. Now you can write out your full justification, so I'm just skipping ahead here. Our second, sorry. Our second limit is going to be the other piece, and you plug in 3 and you get 3b plus c plus 9. So for the seventh to match, 3b plus c equals -5. So now we have two restrictions, and these restrictions are not the same. So there is a single point of intersection. Remember, algebra maybe. You have two linear equations, right? And they're not the same, and they're not parallel. So they have one point of intersection. So we're going to express that system of equations. And notice 3b is just 2b plus b. And since we know b plus c is 1, we just get 2b plus 1 is equal to -5, or b is -3, which means that c is 4. So if b and 3, if b is equal to -3 and c is equal to 4, f is continuous over the real numbers. Hopefully this helped out. And try to focus on the four-step process, which is express all inequalities as intervals, determine continuity in the interior of those intervals, then determine continuity at the bounds of the intervals, right at the extremes, and finally combine any equations into a system of equations, or like in the first one, to solve it directly. Hopefully this helped, and good luck in your studying.